Check, check. Hi guys, am I audible and visible? Are you all able to see me and hear me? Alright, very good afternoon everybody, and as I always say, Andariki Namaskaram, Ellargu Swagatam, and a very warm Vanakkam to Vedanta J English channel. This is me, your master teacher Nabumita Parajaji, and right now we're going to do some of the easy kill topics or easy kill questions from inorganic chemistry that is meant to boost your marks by 10 to 20 marks. So everybody, are you all ready? Quickly go and call up your friends, and do not forget to like the session everybody, and let us begin guys. Come on, come on, come on. Quickly go and call up your friends everybody. Quickly go and call up your friends. This session is going to be important. This session is meant to bring you, at least this session is meant to boost your marks by 10 to 20 marks. So quickly go and call up your friends everybody. I'll wait for 2 minutes. I'll just drink some water before we start the session everybody. Yes guys, come on. No more hope. No, there is still hope guys. There is still hope. Let's not say that. Yes. Hi Sanjita. Hi Mahesh. Hi Abhinaya. Hello everybody. Quickly go and call up your friends everybody. Let us begin. Let us begin the session. Let us begin the session. Also, do not forget to like the session guys. Yes, shall we start with the session? Namaste bache, namaste, very good afternoon. Alrighty, so let us begin with the session everybody, but before I start with the session, let me tell you that Vedantu has gone offline. We are here in so many places and all over India. So if you guys want to meet your master teachers and have a one-on-one class with us, meet us physically, talk to us and everything, then this is the number where you should call, and you should definitely join our sessions guys. It will be amazing. Okay, it will be amazing to see you all in the offline centers everybody. So if you guys are taking a break, or if you guys are taking a drop this year, then do not forget to join Vedantu's classes, Vedantu offline center, because offline is going to be great. Somebody is going to actually be there to make sure that you are doing your assignments. Somebody is going to be there to make sure that you are able to solve the problems right then and there in front of your teachers, right? So that is the best part about the offline. Here we cannot really come and see you that if you are actually solving the problems or not. We do give you the homework, but we don't know if you are going to do that or not. Okay, alright, yes. So chalo, let us start with the first question everybody, and the first question is, atomic size of gold is almost the same as that of silver, and it is due to. So guys, these are going to be an absolutely easy peasy biryani tasty questions from inorganic chemistry. Let's see if you can solve it everybody. So tell me, the same crystal structure of silver and gold, is it? Or is it almost the same electropositive character of the two metals? Are we going to talk about that? Is it transition metal contraction in series, or is it the effect of lanthanide contraction? Can somebody tell me? Yes, what is going to be the answer? Somebody, come on guys, go ahead, let me know. What is the answer? What do you think is the answer here? Yes, very good. Abhinaya has told me the answer, and the answer is option D, that is your lanthanoid contraction everybody. What is it? This is the answer is lanthanoid contraction, option D, absolutely right. See, these are the type of questions that may appear in your inorganic chemistry, and it is going to be your win-win situation, isn't it? This is going to be your win-win situation everybody. You guys are absolutely correct. The correct answer is option D, the effect of lanthanide contraction. Chalo. Moving on to the next question everybody. Yes, the next question is, in the periodic table, the metallic character of element, what happens? Is it option A, decreases from left to right across a period and on descending a group? That is, when you are coming down, when you are coming down in a group, what happens? Does it decrease? The metallic character, does it decrease? Not at all. The metallic character actually increases when you're traveling from top to bottom in a group, and as you go from left to right, it decreases. Absolutely. So this is definitely not the correct answer. Does it decrease from left to right across a period and increases on descending a group? Yes, that makes sense. That does make sense. So I think it is option B, but quickly you guys go ahead and let me know, is it option B? Does it increase from left to right? Not at all. Does it increase from left to right across a period? On decrease, and decreases on descending a group? Not at all. So option A, C and D, they seem to be the wrong answer type of question. I mean, they seem to be the wrong options, but option B is the only one that seems to be the correct option here, isn't it? Yes. So this definitely looks like a confidence boost up, isn't it? And these type of questions do come for the inorganic part of the weightage, everybody. So make sure that you guys are paying attention to this session. Yes, you never know, maybe one or two questions of this sort may appear in your exam, and that time you might be able to thank me. So chalo guys, moving on to the next question. Maximum magnetic moment is shown by, everybody take a look at it. See, D5 has how many unpaired electrons? There are 5 unpaired electrons here, isn't it? 5 unpaired electrons for D5, everybody. Is that right, guys? Yes, there are 5 unpaired electron. Yes, for D6, how many unpaired electron do you think you will be able to see? Yes, for D6, how many unpaired electron will we be able to see? We will be able to see 4 unpaired electron, isn't it? 4 unpaired electron. For D7, everybody, 1, 2, 3, 4, 5, 6, 7, that means 3 unpaired electron here, and for D8 you will be able to see 2 unpaired electron. And we all know that the magnetic moment with the unit Bohr magneton is very closely correlated, or it corresponds to the number of unpaired electrons. So if an element has a D5, that is 5 unpaired electron, that means the magnetic moment is going to be around 5.7. Yes, it is going to be 5.7 Bohr magneton. Hence, this is the one that is going to be of the highest magnetic moment. The maximum magnetic moment will be shown by option A. Very good, everybody. Very good. All right. Moving on to the next question, everybody. Guys, this session is not going to be more than 1 hour. Not more than 1 hour. Definitely lesser than 1 hour. I have around 20 to 25 questions like this. I have around 30 questions like this in an organic question. I'm going to solve this within 30 within 1 hour. So each and every question we will be solving it less than 1 minute, everyone. We are solving each and every question in less than 1 minute, everybody. So pay attention and let's solve it. These type of questions you will be able to solve it. Okay. Next question is, angular shape of ozone molecule consists of. Yes, angular shape of ozone molecule, everybody. Does this make sense? So here what do you have? You have 2 sigma bond, because our double bond has 1 sigma bond and 1 pi bond, isn't it? A double bond, my dear students, have 1 sigma bond and 1 pi bond, and this is going to be 1 sigma bond. So that means that there are 2 sigma bond and there is 1 pi bond. Correct, everybody? That means option D makes sense to us, and option D is your correct answer. See, once again, easy peasy biryani tasty. We are taking less than 1 minute to solve each and every question. Does this make sense, everybody? Yes. Are you all liking the session, everyone? Do not forget to like the session, guys. Do not forget to like the session. Chalo. Moving on to the next question, everybody, is the correct order of size for iodine species. What do you have? You have I, you have I minus, and you have I plus, everybody. Correct? Yes, so we all know that I plus, because it is a cation, the cations always have a smaller size than the usual or the neutral atom. Correct? So the cation, they always have a lesser size than the neutral atom, and the anion, that is I minus, will have the biggest size. Correct? So this is our answer, and this corresponds to which one, everybody? This corresponds to which one? It's going to be I minus is the greatest, then I, and then I plus. So I think option D, everybody. Yes, is it option D, guys? Is it option D, everyone? Absolutely. Option D is the correct answer. Very good. Option D is the correct answer. Next question, everyone. Next question. Which of the following has maximum number of unpaired electrons? Okay. Maximum number of unpaired electron, everybody, and atomic number of iron is given to you. It is 26. If it is 26, then the electronic configuration of iron, my dear students, is 3d6 4s2. Yes, this is the electronic configuration for iron. Here, how many number of unpaired electrons do you have? You have here 4 unpaired electrons. Okay, how many do you have? You have 4 unpaired electron. This is definitely not unpaired, s2, so one will be like this, one will be like this is paired, right? Okay, now if we look at option B is Fe plus 2. If it is Fe plus 2, if it is Fe plus 2, then the electronic configuration is 3d6. That means we still have 4 unpaired electrons. Yes, how many do we have? We still have 4 unpaired electron, everybody. Yes, moving on guys, moving on. Fe plus 3. If it is Fe plus 3, then it will have an electronic configuration of 3d5, and that means that there are 5 unpaired electron. More than this, there is not a possibility. We do not have a possibility of having maximum number of electrons than this. D5. 5 is the maximum number of unpaired electron that we can get. So I think option C makes sense to us. Option C is the correct answer. Yes, everybody? Are we getting it? Are we getting it? Is it looking like EPBT, that is easy peasy biryani tasty? Yes, everybody? Are we liking this, guys? Quickly go and share it with your friends, everybody, and let them know that this is a very important session. This can be a rank booster. This can be a mark booster session for you all. This session can definitely boost 10 to 20 marks for each one of you, everybody. Pay attention. We're doing a lot of chapters. We're doing periodic properties. We're doing P block. We're doing coordination compounds, DNF block. We're doing each and every inorganic questions right now, everyone. All right, chalo, moving on to the next question, everybody. The next question is, which quantum number is not related with Schrodinger equation? So here we also have a structure of atom question. Although this is a physical chemistry question, but this is a very easy peasy biryani tasty question, everybody. So tell me, which quantum number is not related with Schrodinger equation? When you solve the Schrodinger equation, which is a huge big equation, if you remember, yes, correct. So Schrodinger equation, when you solve it, you get principal quantum number. Once you get principal quantum number, it is very easy for you to obtain azimuthal as well as magnetic quantum number. But one thing that it cannot tell you is the spin quantum number. Schrodinger equation cannot be solved for spin quantum number. It has no significance for spin quantum number. It does not tell us about the spin quantum number at all. Yes, ma'am, total number of inorganic question per shift. Bacha, inorganic, organic and physical chemistry, each one of them has almost 30% of weightage. Okay, so if there are 30 questions from chemistry, that means 10 questions will be from inorganic, 10 questions from organic and 10 questions from physical. This is what we assume. Okay, max to max, if they change, then there can be maybe 9 questions from inorganic and 11 questions from organic and 10 questions from physical, or it can be, but it is basically 8 to 10 questions from each and every segment of your chemistry. Okay? Alright, next question, everybody. The next question is, which of the following has a fractional bond order? Guys, do you all know the trick how to calculate bond order, everybody? I have told you this long back. Yes, Mr. Rohit 10, what is Schrodinger equation? नजर ना लगे बच्चा, बहुत बड़ा होगा. Tomorrow is your exam, and if you are asking me today, ma'am, what is Schrodinger equation? I do not know how you are going to crack your J. Okay, I have no idea, but anyway, no problem about it. So we have to find out fractional bond order, guys. How do you calculate How do you calculate bond order? I have told you the trick. What is the trick, everybody? What is the trick, everybody? Anybody, can you tell me? Yes. So I have told you that what you need to do is always write first 14. 14 has a bond order of 3. Now what you do, write down here 13, write down here 15. It will have 2.5 bond order, 2.5 bond order. What is 14? 14 is the number of electrons present in a particular species. Okay. Alright, then if you write here 16 and if you write here 12, how much are they going to have? The bond order is going to be 2 and 2. If you write here 11, if you write here 7, the bond order is going to be 1.5 here and 1.5 here. Okay, if you write here 18 and if you write here 10, then the bond order is going to be 1 and 1. If you write here 9, it is going to be 0.5. And if you write here 9, it will be 0.5. Later on, even lesser than this, if you write or more than that, your bond order is going to be 0. That means the molecule does not exist. Okay, that means the molecule does not exist. Alright, yes. Okay, so everybody, let us take a look at it. O2, 2 plus. How many electrons does O2 have? Oxygen will have how many electrons? 8 plus 8, 16 electrons. So if it is 2 plus, that means 2 electrons are less. That means Oxygen has 14 electrons, so you can clearly say that the bond order here is going to be 3, isn't it? Very good. Okay. Now for O2 2 minus, guys, O2 2 minus 16, but 2 minus, that means 2 electrons are extra, so here there are 18 electrons. If it is 18 electron, the bond order is going to be 1 that I have just mentioned here, alright. If it is F2 minus will have how many electrons, guys? F2 minus, F2 has 18 electrons. Yes, if it is 2 minus, that means 2 more electrons are extra. So 20 electrons here, and the bond order is going to be 0. That means this molecule, this species, it does not exist, everybody. Yes. But if we look at H2 minus, just one negative electron, one extra electron. So that means there are 3 electrons, and here the bond order is definitely going to be half, everybody. Yes, the bond order is definitely going to be half, and that is your answer. And that is your answer. All right, everybody. Yes. All right. Okay. Cool, everybody. Chalo. Moving on to the next question, everybody. So yes, your correct answer is option number D. I hope that you guys got it correct. Chalo, next question. An element with atomic number 106 has been discovered recently. Which of the following electronic configuration will it possess? Okay. So here in the options, do you see everywhere they have written radon, 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 radon. So tell me, guys, what is the atomic number of radon? Can somebody tell me? What is the atomic number of radon? Radon has an atomic number of 86. Yes, and here you can see that the element that has been recently discovered, that has an atomic number of 106. So if we subtract 106 minus 86, how much do we get? We get 20 electrons, right? So 20 electrons extra we have to put it somewhere. Now here, according to the option A, see, in option A, what do you have? You have 5F14. So 14 electrons plus 65, yes, plus 7 is 1. That means that 20 electrons we have added after radon, isn't it? We have added 20 electrons after radon. So option A, according to me, should be correct. But let's check out the option B, C and D as well, everyone. Let's check it out. So here you see 5F14, 14 plus 5, okay, that is 19, and here is 7S2, everybody. So that means that 19 plus 2 is 21, does not make sense, okay? Okay, 4F14, but 66 and 7S0, 7S0, that won't be stable. D orbitals have a capacity of holding 10 electrons, and D5 is going to show you half-filled stability. So it will prefer D5 instead of taking D6 configuration. That is why we are ruling out option C, okay? Now look at option D here. You have 5F14, 14 plus 6D1. That's not at all possible, right? 14, 1, 15, 16, 17, 18, 19, 20. 7S2, 7P3 and 6D1, that also does not make sense, right? 6D has to be filled up to quite an extent for the electron to go to 7S2 and 7P3, right? This was what? Auber principle, exactly. So according to all of it, I think option A makes sense to us the most. So option A is our correct answer, all right? Moving on to the next question, everybody. The next question is the electronic configuration of transition elements is exhibited by. Transition elements have an electronic configuration of what? It has an electronic configuration of n-1, d, 1 to 10, and what does it have? It has n, s, 1 to 2 electron. Yes, and that corresponds to, I think, option A once again. Yes, it corresponds to option A because n is 1 to 2, n-1, d 1 to 10. Yes, d 1 to 10. So option A is the correct answer. Option A is the correct answer. Mahesh, I have just given you the trick and I just told you how to find bond order. We just did it, right? We have just completed the question. Don't worry about it. You can just rewind it back a little bit and then you can watch it. Okay, Mahesh? Alright, bacha. Moving on to the next question, guys. The next question is, which of the following electronic configuration is the outermost shell characteristic of alkali metal? Alkali metal. Can you give me one example of alkali metal? Sodium. Sodium is an alkali metal, isn't it? So if I take the example of sodium, can anybody tell me what is the electronic configuration of sodium? Sodium has an electronic configuration of, yes, 1s2, 2s2, 2p6 and 3s1, isn't it? 11 is the atomic number. So 1s2, 2s2, 2p6, 3s1. That means that it can be written as n-1 S2, yes, P6, and then you can write it as N S to the power 1. That means 1 electron in the nth level, and in n minus 1 it will be completely filled. So that is n minus 1 S2 P6 and S2 P1, no. N minus 1 S2 P6 D10 NS1, no. N minus 1 S2 P6 NS1, yes. Option C is your correct answer, everybody. Check it out, check it out, check it out. Bacha, for safe score, I have already made a shorts. I've already made a shorts related to safe score, everybody, okay? I've done it. Kindly check it out. It's there in the channel, guys. Okay, it's there in the channel. All right. Let us go to the next question, shall we, everyone? Yes, let us go to the next question, guys. And the next question is right here, my dear students. Yes. Configuration of Br minus, that is bromine with 1 electron extra, has a configuration Ar 3d10 4s2 4p6. Now, what is the electronic configuration of bromine plus 2 electron? That means bromine, once it has lost 2 electron, then the electronic configuration will be identical to which one of these elements? Will it be selenium, will it be arsenic, will it be gallium, or will it be germanium? Can somebody tell me what is the atomic number of argon? Argon has an atomic number of 18, isn't it? Yes. Now for bromine minus, they have given us that for bromine minus it is Ar 3d10, 4s2 and 4p6. So what is going to be the electronic configuration of bromine? Bromine will have an electronic configuration of Ar 3d10, 4s2, 4p5. Am I right? Yes. So now if I say what is the electronic configuration of Br plus 2? Br plus 2 will have an electronic configuration of Ar 3d10, 4s2, 2 electrons gone from here, so 4p3. So how many electrons are there, guys? 18, 18 plus 10 is 28, 28 plus 2 is 30, 30 plus 3 is 33. And 33 is the atomic number of, arsenic, isn't it? Arsenic has an atomic number of 33. Hence, the correct answer is option B. Am I right, guys? Does it look like you will be able to do it? Doesn't it look like that you will be able to do it? Inorganic chemistry is your secret weapon. It's easy. It is biryani tasty. You guys will be able to do it. Pay attention to inorganic chemistry. Don't let it go. A lot of people will tell you that inorganic chemistry is basically like parrot. You have to learn a lot of things. No, it's all story. It's all story. When you relate it with story, you can remember it, okay? And it's all absolutely common sense. If you have seen the periodic table, you can understand that it is all common sense, guys, okay? All right, chalo, moving on to the next question, everybody. The next question, my dear student, is the ionic radii of N3 minus, O2 minus, F minus. Guys, once again, a simple common sense here. See, N3 minus has the highest anionic charge, right? The moment you see that it has highest anionic charge, that means an anion will always have a bigger size than the neutral atom, right? So here, the first thing that you have to do is find out in which one the first radii size is maximum. The first radii size, it is 1.36, 1.36, not at all. Both the options, let's rule it out, doesn't matter. So now we have come to 50-50 chance, okay, 50-50 chance. See, in 1.71, 1.71, option C and D, both of them, option C and option D, both of them have the first ionic radii maximum, correct? Very good, okay. Now look at O2 minus, again, more anionic charge than F minus. 2 minus is one more anionic charge than F minus, everybody. So that means it will be 1.71, then 1.40 and then 1.36. See guys, without lifting your pen, you are able to solve the inorganic question, guys. Yes, isn't this great? Isn't this great, everybody? Yes, it is. Yes, it is. Okay, moving on to the next question, everyone. The next question, everybody, is K plus, Ar, Ca2 plus and S2 minus contain. Okay, K plus. How many electrons do you expect in K plus? In argon, there are 18. 18 is the atomic number. Yes, K plus. Potassium has an atomic number of 19. So that means K plus will have 18 electrons. So clearly we understand that these guys, yes, Ca2 plus and S2 minus, they are going to have the same electronic configuration, but they all belong to different groups, everybody, right? Because they belong to different groups, what will happen? The atomic size will be different. If the atomic size is different, that means the volume of the atom is also going to be different. And that means, everybody, that option C is our correct answer, isn't it? That means that option C is our correct answer. What is option C? Same electronic configuration but different atomic volume. The atomic volume is going to be different. Yes, everybody? Very good. Chalo, moving on to the next question, everyone. The next question is, which of the following is not isoelectronic species? Now, come on, guys, tell me. Cl minus. Cl minus. Okay, Cl minus, everybody. Can somebody tell me what is Cl minus? What is the electronic configuration of Cl minus, guys? Cl minus, P3 minus and argon. Once again, this is definitely an isoelectronic species. So wrong. N3 minus, Ne and Mg2 plus. N3 minus. So from 7 to 3 minus is 10. Neon has an atomic number of 10. Mg plus 2. From 12, 2 electrons will be lost. So this is also isoelectronic species, definitely. Alright, absolutely great. Okay. Now, if you come to boron, boron plus 3, helium and lithium, yes, they all are going to have, all of them are going to have 2 electrons each. So yes, this is also isoelectronic species. But if you look at N3 minus, S2 minus and Cl minus, guys, N3 is going to have 10 electron, S2 minus will have 18 electron, Cl minus once again will have 18 electrons. So this is definitely not an isoelectronic species. Yes, option D is your correct answer. Option D is not an isoelectronic species. Yes, very good, Kartik, very good. Chalo, guys, moving on to the next question, everyone. Aluminium and gallium, they have the same covalent radius. Why? Aluminium and gallium, why do they have the same covalent radius? Because just before gallium, the whole D block has been introduced, and D block elements, they have D orbitals. The D orbitals have a very poor shielding effect. So poor shielding power of D electrons of gallium atom is the correct answer. Yes, that is the correct answer. The D electrons, they have very bad shielding power. Alright, yes, so option C is your correct answer. Alright. Chalo, guys, moving on to the next question. The next question is the relationship between first, second and third ionization enthalpies of each group 13 element. Guys, we all know that doesn't matter which group, which element belongs to, but if it is about ionization energies, we all know that ionization energy 1 is going to be lesser than ionization energy 2, and that is going to be lesser than, ionization energy 3. Once the atom has given 1 electron, after that, for giving away the second electron, it is going to have certain bit of hesitancy, unless and until if it can give away the second electron, and if it can attain a D5, a half filled a half filled orbital configuration, or a fully filled or completely empty, or a noble gas configuration, only then it would want to give away the second electron or the third electron. So option B is our correct answer. Yes, ionization energy 1 is going to be lesser than ionization energy 2, and that is going to be lesser than ionization energy 3. Am I right, everybody? Absolutely. Chalo. Alright, moving on to the next question, guys. The stability of +1 oxidation state among aluminium, gallium, indium and thallium, it increases in the sequence. Everybody, do we all remember in the P block, the properties of the elements, we have studied that as you go down the group, lower oxidation state, the stability of the lower oxidation state increases because of inert pair effect. Yes, because of inert pair effect, the lower elements, the bottom elements, they do not want to give away more electron. Hence, in the aluminium, gallium, indium, thallium, they all belong to group 13. In group 13, they can either show +3 oxidation state or +1 oxidation state. +3 oxidation state will be shown by boron and aluminium. As you go down the group, indium and thallium will prefer to show you +1 oxidation state rather than +3 oxidation state because of inert pair effect. Yes, alright, everybody. And the stability of +1 oxidation state increases further. So that means that it will be aluminium, then gallium, then indium and then thallium. So yes, option B is going to be our correct answer. Am I right, everybody? Yes. Am I right, everybody? Option B is our correct answer. Well done, well done, well done. Yes. +1 oxidation state among aluminium, gallium and indium, thallium increases in the sequence. stability. Yes, it is option B, guys. Yes, it is option B. It is definitely option B. All right. Yes, definitely option B, guys. No. Yeah. Chalo. Next is BOH3 or BHO3. What is this? This is what? This can be also written as H3BO3 if you remember. What is H3BO3? H3BO3, you know what it does? It can accept, it can accept electrons from water. The moment you add it into water, it forms H4. Yes, it forms BOH4. All right, let me write it like this. It forms BOH4, and here there will be H plus. So it is a monobasic acid and it is definitely a weak Lewis acid. Which one's the Lewis acid? The Lewis acids are always the ones who can accept electron. Yes, what is this? Very good. Who said it? Boric acid. Yes, boric acid is the correct answer. Orthoboric acid, boric acid, yes. It is always. You know what? It's like okay, so imagine, let's say that who is this? Status. Okay, so status is, I don't know, status I do not know what you mean, and Dev I do not know what you mean, but anyway, so status and Dev, let's say that both of them are asking me some money, and imagine if I don't have money, what I'm going to do is I'm going to go ask the Shreya sir that, Shreya sir, please give me some money. Once he gives me the money, then I'll give it to you, right? So are you understanding? This is exactly what is happening here. So orthoboric acid, it does not have its own H plus ions to give away, okay? So what it does is, it takes electrons from water and then it releases one H plus ion. So it is a monobasic acid because it can only give away one H plus ion. So it is a monobasic acid and it is a weak Lewis acid. Yes, okay. Alright guys, so chalo, moving on to the next question everybody. The next question everybody is, carbon and silicon, they belong to group 14, right? We know that, correct? We know that, isn't it? Yes, we know that, right? Okay. Then the maximum coordination number of carbon is a commonly occurring compound is 4, whereas that of silicon is, this is due to, okay guys, this concept, the concept of this question is anomalous property, okay? All right. Yes, what is the anomalous properties of carbon? And not just anomalous properties of carbon, guys. In the p block elements, we have read anomalous properties of boron, carbon, nitrogen, oxygen, fluorine. Each of the first element in the group, they always have an anomalous properties, just like the younger one in your family also has some anomalous property, right? The rules for the younger one and the elder sibling is always different. Exactly like that. You will see that carbon has only covalency is only 4. It does not have empty d orbitals, so it cannot expand its covalency. But silicon does have empty d orbitals, and that is why silicon does have empty d orbitals, and that is why silicon's covalency can go up to 6. Okay. So availability of d orbitals in silicon, not option D, it should be option C everybody. This is option C guys. Availability of d orbitals, that means this is option C. Option C is your correct answer. Yes, very good. Game squad, absolutely right, absolutely right. Stylish Chetan, I do not know Telugu, but I only know Andariki Namaskaram, okay, not more than that. I only know Andariki Namaskaram, that's it that I know, okay. Alright, yes, okay. Very good Sudha SS, very good geometry. Yes, this is from P block. Yes, this is anomalous properties of the first element. So guys, are we sure? Yes. 90 percentile just by studying inorganic, Sasha, that means that you will have to be really sharp with your physics and mathematics also. Because if you want to score 90 percentile, that means that you will have to do a lot of questions. You will have to do a lot of questions. I think 90 percentile you will be getting around 120 to 100 marks, right? 100 to 120 marks will fetch you 90 plus. That means that you will at least have to do 30 questions. 30 questions you will have to solve in the whole question paper. 30 to 40 questions you will have to solve in the whole question paper. So I think maybe. But that means that you will have to solve each and every question of inorganic chemistry. You cannot leave even a single one. Okay? Yes, IITN boy, absolutely right. You are right. Chalo bacha. Moving on to the next question, guys. The next question, everybody, is the element that shows greater stability to form p pi multiple bond. I mean, come on. P pi multiple bond, the first thing that we study about carbon is that the carbon has catenation properties. However, catenation is not a part of your syllabus. But why does carbon form catenation? Why is it that carbon can show catenation? Because it can form multiple p pi bond, not only with its own atom. Yes, but it can also form p pi multiple bonds with the similar size atoms like nitrogen and oxygen as well. Right, everybody? Yes. But the qualifying marks, so I will not be able to see it right now. I want to score 97 plus in chemistry in doing organic and physical, but scared about inorganic. Game Squad, I think I have helped you a lot. And I kept telling you that you have to watch all the other sessions that I've taken. Inorganic is not the tough. Yes, inorganic is basically the easiest. I think you can do it, but don't worry about it so much. Yes, just calm down. Keep solving the questions. I promise you will be able to do better. Okay? I promise you will be able to do better. Just calm down. Read through, solve questions from inorganic chemistry. I think you can do it. Okay? Alright, next question everybody is, copper becomes green when exposed to moist air for longer period because of the formation of a layer of cupric oxide on the surface of copper. Cupric oxide, not at all. You know what copper forms? The moment copper reacts with moist air, it can form CuOH. Yes, that is copper hydroxide, and it forms copper carbonate, and together the hydroxide and the carbonate together is called as copper patina. It's a green color. This is why Statue of Liberty, which is made up of copper, is absolutely green, because that is copper patina. And that copper carbonate, metal carbonate, what is it going to be? It's going to be basic in nature, isn't it? So option B, it is because of the formation of a layer of basic carbonate of copper on the surface of copper, guys. I think option B is your correct answer, and this has come in JEE Mains 2014. In JEE Mains 2014, this question has come, everybody. So go ahead and take a look at it. Alright, option B is your correct answer. Moving on to the next question. Synergic bonding involves. This we have studied in coordination compound, where there is anti-bonding, there is back bonding between a metal and metal carbonyl. Yes, between a metal and a carbonyl, that is carbon monoxide, which acts like a ligand, CO. Yes, between a metal and carbonyl ligand, there is a synergic bonding, back bonding, anti-bonding, right? We have studied it. And that, why does it happen? That's because the ligand can transfer electrons to the metal, and the metal then sees that you have empty room, you take the electron back. So the ligand gives the electron to the metal gives the electron back to the empty what? Anti-bonding orbital of the ligand. So that means it is option C, both A and B. The transference of electron from ligands to metal and the transference of electrons from filled metal orbital to anti-bonding orbital of ligand, everybody. Yes, guys, this makes sense. Yes, does this make sense, guys? Does this make sense, everybody? Alrighty, moving on to the next question, guys. What is the relationship between the following two linear complex ion? Guys, look at it. The moment you see that this is SCN minus, okay, thiocyanate. Thiocyanate is an ambidentate ligand. That means that it has donor site as sulfur, it has donor site as nitrogen, right? It can use simultaneously only one donor site, but at a particular point it will act like a monodentate ligand. However, whenever ambidentate ligands are seen, that means that it will always show you linkage isomerism. Okay, it is always going to show you linkage isomerism. Bacha, there is nothing called as guessing the options. Okay, there is nothing as guessing the options. If somebody has told you that you can guess the options in JEE, it's a stupidity. It's a 2-year course that you have to study in your 11th standard, 12th standard, then you appear for the exam to be able to clear it and get into your dream college. This is absolute stupidity, how to guess the mark. If you are guessing the question, then nobody would have been studying for 2 years and working so hard to make sure that they get into your dream college. Yes, guessing does not work. Study, focus, practice problem. This is the only way you do it. Yes, I hope you understood. Chalo guys. Moving on to the next question. What are the geometric shapes and the oxidation number of the copper atom respectively for the complex? Okay. CuNH3 4OH2 2. Okay, how many ligands are there? There are 4 plus 2 ligands, that means 6. 6 is the coordination number. 6 is the coordination number. The moment you see 6 coordination number, you know that it is octahedral. You know that this will be the octahedral geometry, right? Yes, absolutely. Now let us find the oxidation state. So Cu we will write it as X, okay? NH3 is a neutral ligand, so 4 into 0 plus 2 multiplied with OH. OH has a minus 1, yes, and here you see there is 2 plus, everybody. So it will be X plus 2 is minus 2, and if this goes there, then what will happen? OH2 into 2. There is some mistake here then. There is some mistake here. It should not be plus 2 here. Actually, you know what? We do not even have to do it, okay? We do not even have to do it. The moment you know that it is octahedral complex, and according to the options, you can directly see that option D has octahedral in the option. So yes, it is going to be option D, octahedral. Okay? Moving on to the next question, an example of a double salt. Guys, I'm not kidding. This has come in JEE Mains, guys. This has come in the JEE Mains, and the first page of coordination compound tells you that Mohr salt, yes, Mohr salt, potash alum, these are your double salt. What is the difference between double salt and a complex compound, that is coordination compound? We all know, isn't it? Yes, so it is Mohr salt, okay? Yeah, it's not just OH, it's OH2, it's written. That means water. Water is also a neutral ligand. That's why we got confused. Sorry guys. Water is also a neutral ligand. So it will be X plus C, NH3, 4 into 0, OH2. See, guys. Okay, very good. No, Vedant, no. Game squad, everybody, please pay attention. See, in this case, the compound that is given to you, everyone. Okay. This is very nice. What a great example we have got. See, the compound that is given to you is Cu, NH3, 4, OH2, 2. Acha, what is OH2? Don't you think that OH2 is basically H2O, am I right? OH2 is basically water, right? And water as well as amine, both of them are neutral ligands, guys. So X plus 4 multiplied with 0 plus 2 multiplied with 0 is equal to plus 2, okay? So here what is happening? X is equal to plus 2. So hence plus 2 is the oxidation state. Plus 2 is the oxidation state. Now is it easy peasy? Very good example. We would have missed out on it. Thank you. Who told me that it is not OH, ma'am? It is OH2. Absolutely. You have reminded me. You have told me. Thank you so much. So this is a great example. Read the question carefully. See, this time what I did was I also did not read the question carefully. And I thought that because the octahedral, so I clicked on it. But this is one way to guess. Otherwise, yeah, that's how it is. Okay? Chalo guys, moving on to the next question. The next question, everybody, is both geometrical and optical isomerism is shown by. Okay. Geometrical isomerism bole to cis and trans, right? Cis and trans, and optical isomerism dextro-levo, everybody, right? These are the two types of stereo isomerism. So CO, yes, EN2, right? EN here, right? We can do EN here, and we can do Cl and Cl. So this will be able to show you cis and trans, am I right? This will definitely be able to cis and trans. Acha. Now tell me something, everybody. Tell me something, guys. Do you think that this will also be able to show you dextro and levo rotation? Yes. Will it be able to show you? Yes. Come on, guys. If you do the mirror images, will it be superimposable, non-superimposable? Yes, very good, everyone. MAA3 does not, but this is not MAA3, right? This is what? This is MAA2, A2. What is this type? This is basically MAA. AA is basically a bidentate ligand, MAA2, B2, yes, and this will be able to show you both geometrical as well as optical isomerism. If you want, you can draw the structure and figure it out that yes, what I'm telling you is the correct answer. Okay, yes, this is the correct answer. Alright everybody, very good guys. Moving on to the next question. Amongst H2O, H2S, H2Se and H2Te, Yes, the one with the highest boiling point. Obviously water, because water has what? Hydrogen bonding. So option A is your correct answer. That's it. Easy peasy, biryani tasty. Easy peasy, biryani tasty, isn't it? Very good, guys. Very good. Chalo, next question, everyone. In XEF2, XEF4 and XEF6, the number of lone pairs of xenon are respectively. Chalo, let us draw it. XEF2, F and F here, F and F here. Xenon has how many electrons? Xenon has 8 electrons. So 1, 2 gone. Yes, 3, 4. Yes, 5, 6. And here 7, 8. Yes, so that means that 3 lone pairs. Alright, now let us do it for XEF4. So 1F, 2F, 3F, here 4F. 2 lone pairs, 1 here, 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 8 done, 2 lone pairs here. For XEF6, we will have 1, 2, 3, 4, and 1, 2, 3, 4, 5 and 6, right? So these many fluorines are here, these many fluorines are here, 1, 2, 3, 4, 5, 6, 6, but xenon has 2 more electrons, so here, this will be distorted octahedral, 1 lone pair, that means it is 3 to 1, option D is your correct answer. And guys, I think we are done. We are almost done. Which of the following compounds is the most sensitive of light? Is it AgCl, AgCN, AgI or AgBr? Okay, for this question, you all know that whichever is the bigger size of the anion, that can actually, that can actually just leave it. Why? Because bigger size of the atom means, or bigger size of the ion means, the bond is going to be weak. So yes, AgBr. We all know that fluorine, chlorine, iodine, bromine, isn't it? Yes, bromine is at the end. Bromine is the biggest size. So that is why AgBr is going to be the one that is light sensitive. Alright. And with this note, guys, we have come to the end of it. There were 62 slides. That means there were 60 slides. That means there were 30 questions of inorganic chemistry that I have done right now, everyone. If you have paid a little bit of attention, I believe that you will be able to do it. And this was all done within 1 hour. 30 questions from inorganic chemistry we have solved less than 1 hour. Every question we have solved within less than 1 minute, everyone. With this note, guys, I'm gonna see you in the next predictor paper session that we are taking today. I'll be coming at the end. I'll see you. All the very best. Lots of love. Study well. We'll see you in the paper discussion. All the very best. And please do not forget to like, share and subscribe to our channel. Vedantu J English channel has been trying to help you as much as we can. Okay? Chalo guys. Bye bye. Yes. Bye bye. Okay. Bye. See you. Iodine is the biggest. Fluorine, chlorine, bromine, iodine. Now, but still it is AgBr. AgBr is the most sensitive of light, okay? It is always AgBr that can show you the most amount of the sensitive. Sorry guys, sorry. Yes, AgBr is the most sensitive to light, okay? It's always. In fact, it is, I think, it is also used in the, wait a second. Yes, it shows very unusual sensitivity to light. Okay, yes, it shows unusual sensitivity to light. And yes, Satya Vijayeshwar Reddy, please tell me, Saranya, I do not know Chennai when we are coming, but definitely soon. Keep letting everybody know. Keep letting everybody know, and we will definitely come. Okay? Yes, AgBr is in fact more sensitive than AgNO3, and it is used in the photographic plate as well. Okay? It is used in the photographic photographic plates as well. Paste, it seems, apparently. I've just said paste. Okay? Alright, everybody. So yeah, that's it. Okay? Okay? Yes. Shall we move on? Shall we? That's it. Done. Okay? That's it. Chalo guys. With this note, tata bye. I'll see you guys very soon. All the very best. I'll be sending you the PDF in the Telegram channel. Go check it out. Okay? You have all the questions. Practice them once. Okay? Organic chemistry will be taken care by Durgesh Nandini ma'am. Okay? Bye bye. I only teach you inorganic and physical chemistry. Here. Chalo. See ya guys. Bye bye. Have lunch and get ready for